I see the usuals piling in here on our Zoom chat. Always a pleasure, folks. We really do appreciate seeing you every Thursday. And yeah, please, we're live on YouTube, Twitch, Twitter, Facebook, etc., here on Zoom. Please let us know where you're joining us from in the chat, wherever you are joining us from and wherever you're watching. I am coming to you from beautiful downtown San Francisco, California, and our stalwart host, Dr. Satya Malik, is coming to us from
San Diego, California.
And our illustrious guest, Jacob Marks. Where are you joining us from today, Jacob?
I am in New York City. So if there are doors crashing behind me, it's just hustling and bustling as New York is.
The Big Apple, baby. The city that never sleeps. I love it. That's great. I don't think this is maybe only like the second or third time we've ever had a person on the stream from New York, which is kind of surprising. Hello, Columbia. Hello, Richmond, Virginia. Love to see it, folks. We love to see it. Hello, India, over on LinkedIn. We're also back on Facebook streaming here this week because Instagram kind of didn't do much. Hello, Hamburg, Germany. Hello, India again here in the Zoom chat. Yeah, we're super warm here in the Bay Area recently. Unseasonable warmth. I hate it. Basically, if it gets above 75 degrees, it just it's too hot. It's too hot in San Francisco, man. Like I don't like that shit.
And if it is below 70, then it's too cold.
Well, not here. It's fine. In the Bay Area, it's fine. But I mean, they've been getting like 110 degrees, 113 degrees in Henderson, and it's just nuts. Hello, Omar from Egypt. Hello, South Africa.
All right.
From all over the world,
folks. Yeah, definitely.
Yeah.
I think let's go ahead and if you're ready, boss, let's get started.
All right, so let's get started. Hello, everybody. Welcome to OpenCV Live. I'm Satya Malik. I'm the CEO of OpenCV.org. Our guest this episode is Jacob Marks of Voxel51, an OpenCV member organization. By simplifying and automating how you explore, visualize, and curate visual data, Voxel51 lets you test and refine your models alongside the datasets they need to ensure robust, accurate results. We are excited to see what Jacob has to show us today. But before that, as always, this show is co-hosted by Phil Nelson. He also produces this show. He is the director of content and creative at OpenCV.org. If anything goes wrong, it is Phil's problem.
That's right.
All right, Phil.
We are all about the boom here on OpenCV Live, episode 137. We are approaching the vaunted Simpsons 138th episode spectacular number, and I, for one, am super jazzed about it. I'm also your co-host with the co-most, the second banana, who is second to none. I'm your plus one and only, and I'm Mr. Nelson if you're nasty, but you, my dear friends here on OpenCV Live, can call me Phil as per usual. I'm here to remind you of a few things that we do on every single episode of OpenCV Live, the first of which is a special giveaway to you in the audience. Stay tuned. Later in the episode, I will be asking a trivia question based on the presentation from our guest, Jacob Marks, and the first person to answer that question correctly here in the Zoom chat will win the OpenCV course of their choosing. You can see what courses are on offer by going to opencv.org/university. Take a look-see, do a little window shopping, as they say, and even if you don't win our giveaway today, maybe buy a course for yourself, upskill, get a new job, get paid more at your current job. That is what OpenCV University is all about. Education from experts in the field, not some ridiculous influencer that's never had a real job, actual professionals that do computer vision work. Also, we're taking questions from you in the audience, and we will do our best to answer them directly, as the late great Satoru Iwata would say. Please use the Zoom Q&A button at the bottom of the chat during the show at any time, and we'll do our best to flow that question into conversation as it makes sense. Also, we'll save some time at the end of the show for questions we don't get to during the presentation. You can ask your questions wherever you're watching. We are live on, according to Restream, Facebook, YouTube, Twitter, I'm never calling it X, LinkedIn, and Twitch, as well as here on Zoom. We love to see it, folks. A big shout out to everybody watching across Al Gore's internet. With that being said, we got a couple of small things to talk about at the tip top of the show here. The first of which is the exciting upcoming OpenCV. We will be live in Seattle for CVPR 2024, Seattle, Washington this year. That is next week, June 17th through the 21st. You can still register. There's still decent Airbnbs available. Last I looked, all the hotel blocks are, of course, sold out this close to the show. OpenCV will be at booth 1920, 1920. Surrounded by some heavy hitters this year. Pretty excited about it and looking forward to it. This will be our biggest booth ever, and we have some exclusive conference swag for you all. There's some limited edition CVPR 2024 stickers that say that are holographic, those sticker mule holographic ones. They say Open Source Computer Vision Library, OpenCV logo, and CVPR 2024. Those are limited to 150. I will be parceling them out 50 per day for the 3 days of the expo. So if you want one, show up early, either on Wednesday, Thursday, or Friday. There's also some awesome parties going on, being hosted by our good friends at Intel, and also featuring our guest, Jacob. He will be at both of these things, apparently. So on Monday, there's the AI Summit. Intel is doing these AI Summits around other events. They're trying to bring AI everywhere, and this is the first one here at CVPR. Really looking forward to this. I will be getting in a little bit early on Monday, and so hopefully I'll be able to be here for most of this event. It starts 1 p.m., goes till 6 p.m. There's a couple of workshops. Our friends of the show, Paula Ramos, Raymond Lowe, and Kevin Hartman will be there. Super excited to see the homies from Intel. Really looking forward to it. Also on Thursday, June 20th, there is the CVPR networking meetup, also sponsored by Intel. Last year, this is the second year they're doing this meetup, and Satya and I had the pleasure of, and Jacob as well, had the pleasure of being there last year, and it was an awesome party. I think a lot of people see the name Intel still, and they're like, the party cannot be that fun. You're wrong, my friend. You're absolutely wrong. Intel throws great parties. Yeah, Intel throws great parties.
Does really nice parties. We also went to the 49ers stadium, right?
Yeah,
Which was awesome.
Yeah. 50-yard line at the Levi's Stadium. That was incredible, definitely. And of course, me being me, I had to wear a Colin Kaepernick jersey, but I did not get in trouble for it, kind of disappointingly. Anywho, I think that's all we've got here at the top of the show. We can keep the train rolling here and remind people that OpenCV is a nonprofit organization that runs a open source computer vision library licensed under the permissive Apache 2 license, which means you can do whatever the hell you want with it and you don't have to pay us a dime. All you have to do is acknowledge that you used OpenCV, much like you must acknowledge your tribal chief. Satya, can you talk a little bit about why it's important to support OpenCV and a couple of the ways that people can do that?
Well, so OpenCV, as we all know, it is the biggest computer vision library in the world. It's downloaded about 20 million times a month. We keep miscalculating it. Once every time we always underestimate it, but I think now we have got the right estimate after doing all the calculations. So it is 20 million times a month it is downloaded, and it is used by, people don't realize that the first autonomous vehicle that won the DARPA Grand Challenge in 2005 actually used OpenCV as the computer vision library, right? And the car, Stanley, it's in the Smithsonian Museum now, and so that's a big honor for OpenCV. Not only that, when NASA sent its helicopter,
I'll bring Stanley up in the screen share here as you're talking.
Yeah. So when NASA sent its helicopter to Mars last year or a few years back, that too used OpenCV heavily, right? So it's a very important library. Everybody uses it, and very few people actually contribute to the library, both in terms of code or in terms of cash, right? So we accept both code and cash. If you're able to contribute in any way, please do. More importantly, if you can get your organization, your companies to contribute to OpenCV, right? That would be great. Recently, Qualcomm became a gold member of OpenCV. And we also have, ARM became a gold member recently. We also know that some companies will match your donation because OpenCV is a 501c3 nonprofit organization. Some companies, your company may actually match the donation you make to OpenCV. So please consider that and let your company know if you make the donation
In some
And
cases, they will even actually match your labor. If you do
yes,
some work on an open source library like OpenCV and you bring it up to your boss or supervisor or whatever, some of these larger organizations will match the donation in cash that you have given in time, which I think is pretty neat.
yeah, and I think it is Apple that gives you about $1,500 for 30 hours of work, something like that. I don't know the exact numbers, but if you tell your, if you donate time, like if you mentor an OpenCV intern, or in some ways you donate your time to OpenCV, then your member organization will donate cash to OpenCV. So
Yeah, and
yeah,
if you have
very
any
important to
questions
keep
about
the.
if you have any questions about these memberships, again, find us at CVPR. We would love to talk to you about it. We'll have a little brochure there for you. In addition to being able to answer any questions that aren't answered on the website or in the documentation, we love seeing people face to face. It's always a great part of these events. Also, you can sponsor us on GitHub. You can go to github.com/sponsors/OpenCV. We have 7 sponsors. That's +1. I'll give them their 5 seconds of fame. Thank you, Victor. Thank you, Jesus. Thank you, Blue Jay. Thank you, Amigu. Thank you, Ad16. Thank you, Ross Newman. And thank you, Rudis Labs. Thank you so much for supporting OpenCV and open source computer vision and AI, because the most consequential advancements should not belong to the privileged few, but belong to everyone. You can also buy OpenCV t-shirts. OpenCV.MySpreadShop is a 15% off of everything sale going on right now, and that includes our popular I Love OpenCV t-shirts in 3 different flavors: English, Simplified Chinese, and en Espanol. So check that out.
That's awesome.
Yeah. All right, I think that's it for me.
I've got to get me one of those t-shirts.
Please do. Yeah,
All right,
these
so
sales come pretty often, but 15% is a pretty serious one. So go check it out.
So the floor is all yours. Start with a short introduction, and then we'll go over your presentation or the demo.
Absolutely, absolutely. So, hi everybody. I'm Jacob. I'm a senior machine learning engineer and researcher at Voxel51. So I'm going to be sharing with you a bunch of stuff about our open source library 51, which is really a library that helps you to understand your data better. So we're talking about visual data, things like images, videos, point clouds like LiDAR and radar, mesh, PDFs, basically all of this unstructured and semi-structured data that includes so much value and rich information inside of it, but it's often hard to navigate and to parse and to filter and query and visualize when you're dealing with things at massive scale. So that's what the library is for. The company is currently a Series B company. So we just raised our Series B, led by Bessemer. We're about 30 people. We were started out at the University of Michigan a few years back. I've been here for about a year and a half now, and my background.
Wolverines.
Go Wolverines, go Wolverines. And my background's actually in physics initially. So as a very random aside, it's fortuitous that this is the 137th episode of the podcast, because when you mentioned that, it clicked something in my brain. There's this this constant called the fine structure constant in physics, which is almost exactly 1 over 137. It's just this really coincidence that comes up.
Oh, I love it.
And yeah, amazing.
It was obviously it was predestined as
Yes.
neuroscience.
Exactly. And you mentioned you guys are going to be there at CVPR. Voxel51 will also be there in full force. More than half of our company will be there. We're going to have a big booth as well, and I think we're going to be the lanyard sponsors. So if you have a lanyard, if you are there at the conference, you will see our logo front and center.
Hopefully everyone's lanyard will have the Voxel51 logo and an OpenCV button on it.
How big has the team grown to now?
We're 30 something right now. We're growing very rapidly. So if you are looking for a job in computer vision, visual AI, data centric AI, if you care about any of those things, which I assume that you do if you are watching or listening to this, then go check out our website, because we've got like 10 jobs posted.
Oh, wow.
We're growing very quickly.
And if you think that you're not prepared for the job, you can take OpenCV University courses.
University, that's right.
Exactly.
Synergy,
yeah.
Satya. That's
we love.
Is Voxel51 a fully remote company, or do you have offices?
We are fully remote. So
wow.
any offices. I actually was based in the Bay Area for the last 7 years, and I just moved to New York like 3 months ago to be closer to family. But we have people all over the country and some people internationally.
Awesome. Sounds like a heck of a place to work. So go check out those job openings, everybody.
So should I share my screen and get going?
Yeah, please.
Yeah, go for it.
I'm going to share my full screen because this will involve looking at
Brave.
things. What's up?
Said brave. That's brave of you.
Yeah, we'll see how it goes. And I've also got Copilot turned off. No autocomplete. This is going to be all raw. So the 51 library is an open source library. So very much like OpenCV, we care a ton about open source and building out in the open. You can contribute to the project as well. You can install it via PyPy package manager. So all you need to do is hit install 51, or you can clone it from the GitHub repo. It works on pretty much all platforms. So it's really easy to get started with. Once you've installed it.
Quick question, sorry for the interruption. Where does the number 51 come from?
That's a great question. The founders like to say that they had 50 bad ideas before this one. But I think that it's related to the fact that the company started out as a video analytics platform. So that's where the Voxel is from. It was like, and I think that they were trying to make a play on like Area 51.
Right.
Well,
So,
everybody.
so it's not like Heinz 57 or Formula 409 or whatever.
Well,
or Formula 420 for those who partake.
Today there are a lot of companies that are like 11 labs and 12 labs, and
right.
there are these numbers associated with them. Who knows where those numbers come from? So you can lump us into that group.
Right.
I like it.
So the 51 library, once you install it, just pip install 51 or clone the repo and install it from there. You can import the main library, just import 51. There's a few other modules that are relevant here. There's the 51 Zoo, which gives us access to a bunch of models and data sets that we can just load in without really doing anything custom. But of course, you can bring your own data and models. 51 Brain is a suite of ML-powered routines. And then there's just this view field, which is going to help us to do filtering and querying. So lots of modules. We're not going to import anything else for a while. This is all the imports, and we're going to actually interact with data now. So it's easiest to start by showing you this quick start data set. So this is a subset of the Microsoft COCO data set. This is the Common Objects in Context data set. So we have this representation.
Co-star of many episodes of OpenCV Live is Coco.
I'm sure. It's popular for a reason. We love to show it all the time. Now, of course, you can work with lots of different types of data. There are many different data sets that one could show these types of workflows with. I'm just going to do this as the easiest way to get started. So the data set has this like kind of logical structure. It's built very much on top of MongoDB, another open source project, because of the non-relational document structure of MongoDB and how that really fits into the fold of computer vision data, where you could have an arbitrary number of detections or key points. You could have some images with classifications or segmentation masks, and some may not. You could have different numbers of predictions fields. It's like very flexible schemas you want some way of representing efficiently and being able to query efficiently. So we have this data set. We already have these ground truth labels on it from the COCO labels, and then we've got these predictions. We can inspect the data set, so I can look at the first sample in the data set, and I can see things like these detection objects. So these are documents inside that encode a bunch of information about a specific object detection. So I have like a unique ID, I've got a label, I've got a bounding box. So we've got some representation of where in the image that bounding box actually is, the size and its position. And we can scroll through and inspect all this stuff, the predictions and a bunch of other fields, but this is often not the best way to deal with data like this. So one thing that we can do is, instead of just actually inspecting this in a code and getting a printout, we can visualize the data. And so we can do that using the 51 app. So this is essentially a visualizer that takes this logical data set that we have, where we're pointing to the paths of these media files on disk, or in the cloud if you're in 51 Teams. And you can then open up the app in your browser, or actually in a cell of the Jupyter Notebook. If you here I passed in auto equals false. So if you don't pass in auto equals false, it will display in the output of the cell in your
Oh,
notebook.
nice.
And you can,
So
That's
will it,
slick.
you can use it even in Collab, right? This is
yep,
going to pop
it
right in.
works in Jupyter, VS Code, Databricks notebooks, Colab, all over the place.
That's awesome.
Sick.
So here I'm going to go back to auto equals false here. And there's a one-to-one correspondence between what's happening in the app and the data model itself. So any changes you make to the data set via code will propagate into the app, and any changes you make in the app will propagate into the code. And that's kind of the way that we like to have things represented, is anything that you can do in the app. It's basically like a wrapper around an SDK method that allows you to more easily interact with the data in some ways. So you can scroll through images, and you can see this as being potentially like a better way to interact with a lot of images than, for instance, a file explorer or a file browser.
Right.
But you can also do things that are a little bit more flexible than that. So I can look at my label
So
field.
what people may not realize here is that, not only is the data shown, the bounding boxes associated with the data is also automatically shown without doing you explicitly doing anything, right? So
Yes.
that's
So
very
because these bounding boxes, and this is not just for bounding boxes, we have the notion of like these label types for classifications, detections, key points, polylines, segmentation masks, lots of different things, and soon a bunch of multimodal label types. And all of these things are like understood and interpreted by the 51 dataset structure, and they are represented and visualized for you. And not just like visualized, you can interact with them. So I can say, this bounding box, is this actually a bird or not? I can look at these and like actually click on them and say, okay, this looks like it is a bird, but maybe there's not a sheep here. So I can look at this sheep prediction. Where's the sheep here? Let me click on that. Let me actually clear all of these and go to the sheep. And I can tag that.
I'm disappointed that you're not using something to generate AI sound effects for each animal,
Yeah, well,
That's version 2.
you can do that. We can certainly go there. But I can tag this as a mistake, for instance. And now that's on this particular label. And if I were to go
Definitely an odd looking sheep.
yeah, so I could go back to the data set and I could look at like the data set dot first here. Oh, this is the challenge of not having autocomplete. And
already just fully dependent on it. I understand.
yeah, right. If I load it here, there should be, I should get a tag that shows up here for that being an erroneous label. Ideally, it would show up there. But you can look through them. You can even filter by these things. So I can filter by just person detections, or I can filter for cars, or I can filter for things that don't have these. So omit tables with these labels. I can filter by more things as well. So these are my ground truths. I can also filter for predictions, which for instance have like a high confidence. And I can say, now I can actually say, okay, this is the mistake or not, but the mistake was a low confidence prediction. So that's not going to show up. But if I reset that and I look at the mistake, it'll show up here. So I can filter by all these different things. I can filter by whatever properties I'd like. They can be bools, ints, floats, date time objects, a bunch of different things. And once I've found a view that's interesting to me, so let's say I have these like high confidence samples that I want, I can reset this, and I can let me say I want to only look at my high confidence samples, and I can turn this into a view stage, which represents symbolically that sequence of operations to perform that filter, to filter for high confidence predictions. And so here I can see this is like the logical representation of the fact that I'm filtering for things that have above an 80% confidence or 0.8 confidence in this. There are chats coming in. I'll let you guys like moderate if there are questions for me or not. I don't.
I'll take care of them. I'm used to cracking the whip at these fools.
Cool. And these view stages are a way to like logically, symbolically interact with the data itself. So I can add view stages. So like I could say, I want you to shuffle the data, and now it shows me the data, the images in a different order, for instance. Or I want to limit this view to 10 samples. And all of these things are things that you can also do via code. So I can take my data set and limit it to 10 samples here, and I can see the view stages represented down here, and then I can inspect this and interact with it. I can then shuffle this if I want to. I can keep on composing these. I can filter on specific things if I'd like, so I can like match for images that have a certain criteria in them, and all of that is basically like one-to-one correspondence with what you'll see in the view bar. And once you have a view that you like, you can even save it so that you can come back to it later. So I'll call this my 10, I'll call this like 10 high conf. I saved it, and now I can go over here and I can reload it. So if you're finding like mistakes in your data, or you're finding interesting subsets and you want to be able to revisit these things in the future, you can, once you have this, you can actually go back and see these save views in the future without having to reproduce all those steps of logic yourself. And all these save views are also visible in the SDK as well. But we can do more than this. So these are just very simple queries and filtering operations. We can interact with.
One question. When we are working on this, obviously it's not cloning the data set. I'm guessing that you have one COCO data set, and then you're just keeping track of the annotations. Let's say the example that you gave, right?
Mm-hmm. So you're not cloning any of the media files. You're pointing to the media files on disk. So if I look at the data set values of the file path, I see where these all are.
Got it.
And there are other
so
data
it
sets.
is not on the server, not on the Voxel51 server. It is on your local disk. Okay, got it. Got it.
So this is all happening locally. And I have other
What about
data sets.
versioning? Let's say you did some annotations, right? And let's say it was a mistake. Can you go back to a previous version?
So we have dataset versioning in our enterprise product that is built on top of this open source. So the way that we like to think about it is you can do versioning yourself in some ways if you just basically clone the dataset, because you're not changing like the media files themselves. You're just changing what the 51 dataset is. If you're just the only one working on it, you can kind of build your own solution for versioning. But if you have a team and you need data lineage and to be able to roll back to different snapshots and have different people with permissions to edit versus to administer versus just to view, that's what we need the enterprise product.
Got it.
And I have other data sets which use these same samples. So I can like list out all of my data sets here, and I can see some of them like, in this one, I have a test quick start. So if I do, I'll do like D1 dot load data set test quick start. And now I can look at the values of this. And it's like the same value, the same file paths. So I have it basically a 51 like logical data set structure that's built on top of the same file paths, the same images. But you can work with other things than images. I can show you with videos, with 3D data, with groups of like scenes, essentially, where you have multiple stereo images and then point clouds for LiDAR and radar all together. We'll get there in a minute. But I wanted to show you some cool things you can do once you have your data in 51, because being able to filter by things like the confidence score, the predictions, the label type, the label class, that's valuable, but oftentimes that's not all you need. You want to be able to perform analyses on your data. You want to be able to understand the structure of the data, and 51 provides some tooling for that. So one thing we have is a bunch of plugins. So plugins basically allow you to bring certain types of functionality integrations into 51 to basically apply directly to your data set or this filtered view of your data set. And one of our most popular plugins is an image quality plugin, which is built on OpenCV. So
Sweet. One quick, if I can butt in for a moment, one question from the audience here was about, so because this is all running locally and it's very snappy, they were wondering what kind of machine you're running on. Like, what are your specs here to make it run so fast?
I'm running on a very basic machine. I have an M1, which has 16 gigabytes of RAM.
Okay.
So
Yeah, I mean
nothing
that's
special.
a low end. They don't even sell those anymore. That'd be
They
a,
don't.
these days that would be a refurb on the Apple store. So yeah,
Yeah,
I've got the M1 like Max or whatever, and it's still so fast. Like Apple's really good at this.
they are. They are. I at some point I'll upgrade the computer, but it's been working great for me so far. Usually 51 is not the limiting factor in my performance and my ability to actually understand data and train models and all that.
Yeah, that's great. I mean, that's the lowest. I think it's the lowest amount of RAM they ship with these days as well. So yeah, awesome.
So this like 51 plugin for image quality issues and finding basically computing properties of your images. We have a couple of these operators in the plugin, and I know I'm doing a little bit of like magic here. I basically hit the backtick or tilde button on my keyboard to pull up a list of operators, which includes all of these things that allow us to either like we just press it and it runs a command for us from the SDK, or it gives us an input form, which allows us to configure things. So if I type in compute, I can find things like the brightness. So I can compute the brightness for all the images in my data set or the object patches, and I can run this, and it's going to use some OpenCV functionality on the back end. And now I have a brightness field on my images, which I can filter by. I can see all the brightest or all of the darkest images. I can even sort by this. So now I see in order my images in brightness. I can compute other things, like if I go back to compute, I can compute, for instance, the let's do the aspect ratio. This is just a basic one right here, but I can just look at the aspect ratio of the images. Oh, where did it happen? So in this case, I have to, yeah, so I have no metadata. So I can just compute the metadata. Basically, I'm computing the width and height of all my images. And now I'm going to go back and compute the aspect ratio. And now I have an aspect ratio field. And I can see all the most square images or all the images that are the least square, for instance. And these are very basic things, but you can use a lot of things like this to understand your data, looking at things that have high contrast, that are blurry, that have low entropy. So if there's low entropy, there's not a lot of information in it, for instance. But we can do things that are not just like traditional image quality metrics as well. So we can use embeddings, basically representations of the content of our images in order to probe our data, to search it, to understand the structure.
Very interesting.
So we can, for instance, compute the similarity. So this is a wrapper around a 51 brain method, and I'm going to save this with a certain name. I'm going to do this for all of my images, not just patches. And I'll use a clip model for this, also open source. And I'll use, just for the basics, I'll use a scikit-learn backend, but you could use any of these vector databases, many of which are open source. It's going to create embeddings here.
So for people who do not know, clip is an open source model that, I mean, you can do several things with it, but the basic thing that you do is you can give it an image and it would give you an embedding, right? It could, you could use it to summarize an image, give an image and it will tell you what is, what's inside the image. A summary of the image you can get through clip.
So yeah, so as Satya is mentioning, CLIP is a contrastive language image pre-training model. So it is trained on both images and text. It has some understanding of the semantic content of visual data because it was trained to align the two modalities of images and text. So I can generate these embeddings, these representations for my images, and then I can either with a query image like I've done here. So I basically just chose an image. I clicked this checkbox and now I'm searching by similarity with an image, which is saying, take the embedding for this particular image, compare that to all the embeddings for all the images in my data set, show me the most similar ones, and I can see it's sorting them by similarity. But I can also search with the text prompt. So I can reset this and I can search with a text prompt. So I could say, for instance, a bear. And this should work here. And I see like the first couple of things that show up are bears here. So it's searching and it's sorting everything in the data set by similarity to the text prompt bear. So it's embedding the text prompt bear, and then it's taking that text embedding and comparing that to the image embeddings. So you can imagine
not
this.
Not the kind of bears I expected to see in June in San Francisco. I'll just say that.
Yeah.
So yeah, and this is not a metadata search. This is a visual, visual search.
So to make that point more explicit, I could do something that we know there's no label for.
Yeah. Okay. Yeah.
So I searched for kites flying in the sky, and it gave me a bunch of kites.
Pretty good.
Yeah.
And
So
this is using a CLIP model, but you could use other models. We're pretty model agnostic. 51 tries to put the power in the hands of you, the developer, because we know that in computer vision, there's no one size fits all solution, and many off-the-shelf models could be useful, but you could also want to use your own model. So make it very easy to do that. And you don't have to use a CLIP model. You don't have to use a ResNet model. You can use certain models which are like unimodal just for visual data, certain models that are multimodal that support images and text. We try to make it as flexible as possible.
Right. And this is also great for, let's say you want to, you have a new object. I don't know, kite is already there in the in it, but let's say you have a new object which you do not have labels for in MS Coco. In that case, you could still use CLIP to query MS Coco and find several examples, several hundreds of thousands of examples of that category, and then label it yourself. But at least you have, you already have this Coco data set to start with. You don't have to download all the images. You don't have to write a crawler that goes and downloads all the images. You can do the query on the Coco data set.
You're totally right. And if you're talking about how to label data to start out with,
Yep.
we also have plugins for doing zero-shot prediction, for essentially adding some initial labels to your data from text prompts. So you could use like CLIP models for that. Basically, you have like a preset list of classes that you feed in, and you compare your image embedding to all of those prompt embeddings and see which one is the highest. We have support for, so you can really go to my zero-shot prediction plugins. So we have for classification, I mentioned, you can use CLIP, but also a bunch of other models, because there are many different approaches people have come up with, lots of improvements on the original CLIP. You could also do zero-shot detection. So we have support for YOLO World, Owlvit, and Grounding Dino here. You can do instance segmentation.
Never even heard of those. There's so many new ones like every day.
There's a lot. It's a very fast moving field. But I could, for instance, I know that dog is one of the label classes of Coco, so I could just use that in a traditional object detection model, but I could, just for the sake of showing how this works, I can go here, I can choose YOLO World, and I'll put in a label of dog, and I'm just going to run this on the selected samples, not all of my data set images. And it's going to run this. It's going to take my text prompt that I put in here, and it should populate with some boxes with confidence scores for dogs in the image. But we can also use embeddings to visualize the structure of the data. So this helps to understand if you have like outliers, edge cases, things like that. And so we can do that with dimensionality reduction.
Word embedding in AI, it usually means that it is a vector of numbers, right? So from image, you go to a vector of numbers. It could be 128 bits, etc., right? 128 values, etc. So when we say that we got an image embedding, we found some way of converting this image into a vector. And then when you say that we got text embedding, it means that we found some way to convert this text into another vector, and they could both lie in the same space, which means that from when you convert the image, which could have a cat, it would show a vector, right, in this high dimensional space. And then you could have the word cat could also be a vector in this high dimensional space. And if you have done this embedding correctly, the two things would lie very close to each other, right? The word cat and the image embedding would be very close to each other. And that is why you can say that, oh, when I'm looking for cat, I'm looking for images which have these embeddings, right? So that way, for people who are beginners who may not know what the word embedding is, it might look very fancy. And yeah, the underlying math is fancy, but understanding the basic concept is straightforward.
You're absolutely right. And to show you what these embeddings are, they're on the data set. So I have this field clip embeddings, which I generated when I computed the embeddings. And this stores them in we call it a vector field, but it's really like a NumPy array type thing.
Yeah.
And I'm going to extract them. And now we can see these embeddings right here. We can even like look at the shape of this and see that it is 200 samples we have in the data set. And these embeddings are 512 dimensional because this is a B32 clip model. So basically, there are certain clip models which have different size embeddings. Many models have different sizes of embeddings. It doesn't really matter too much for our purposes, but the higher dimensionality of the embeddings, the more information they can capture in there, essentially. And these embeddings can be used for downstream processing, as in what I'm going to show you, which is the dimensionality reduction. Basically, how do we go from this 512 dimensional vector, which is some arrow pointing in a really high dimensional space, to something that we can actually intuit and interpret and visualize in a human way, which we probably typically need like 2 or 3 dimensions, or you can play tricks with 4 or 5 dimensions to try to understand what's going on. But how do we preserve the structure of that high dimensional space while still making it interpretable? And that's what this technique UMAP does, which is only one technique to do that. There are other techniques like PCA, principal components analysis, you might have heard of, or TSNE, which is a tail stochastic neighbor embedding. Basically, there are fancy ways of taking high dimensional things and trying to push them into a lower dimensional space while preserving some of the structure, either global or local or both. So I'm going to run this. I'm going to generate this low dimensional representation for these embeddings, and you can use whatever embedding model you want, whatever dimensionality reduction technique you want. And now I'm going to visualize them. So I'm opening up a panel to visualize these embeddings that I already generated. And I can see each point in this space corresponds to one of the images in our data set. And I can interact with them. So like I can lasso select this group, and I can see that it looks like this was all food.
Oh, right.
Or what's going on over here, I can see, what is this little cluster? This looks like all dogs and cats and one person.
Slick, very slick.
But this is cool, but it actually gets cooler because we can do things like color by certain properties. So I can color by the brightness, for instance. And in this case, we can see that the brightest samples are all lumped together. And a lot of these are like outdoor, they're like watery scenes.
Right.
But in some cases, this is just, it's just cool, it's just flashy. But in some cases, it actually helps us to understand the data better. And to see that, we can look at a different data set, which I've already loaded in, which is, I believe it is this one. Yeah, so this is the Berkeley Deep Drive data set. I haven't named it properly because I just loaded it in right before this. But this is basically a bunch of images from a data set which includes these images of driving scenes outside. We have some polylines that represent like the lanes. We have detections for cars and stuff like that. We should also have embeddings already on these. And when we look at these, we can start to see there's a really big structure going on here. We can try to investigate this and say, what is this picking up on? And we can color by properties for labels that we have in our ground truth data. And this is just clip, these are, I think actually these are ResNet embeddings and then UMAP again. But I can color by things like the weather and see, does the weather have an effect on this? And in this case, it looks like there is some effect to the weather, but what about other things? Like, what if I look at, for instance, the time of day? And I can see that the time of day almost directly coincides with which of these lumps, I would say clusters, but these are not technically clusters because I haven't done a clustering algorithm on this, but which of these lumps roughly does this correspond to? And I can see this is like one big daytime area, and this is one big nighttime area.
Right.
So
you could actually, this is fascinating, by the way. You could actually go and look at all your bad results, right?
exactly. So now that we have this, we can investigate further. We can inspect and say, well, there are these few dots that are colored differently than everything else. Why don't I just select for those? So I'm going to double click on this night dot up here to get just the nighttime samples. And I'll select just the ones in that cluster and say, are these edge cases? Are they mistakes? What's going on here? And in some of them, they do look like mistakes. Like this doesn't look like a nighttime image, but this one does.
Yeah. Sometimes they are twilight or something like that, right? Yeah.
And then I can look at the other side and say, what about these? Well, some of these, this is a tunnel we're looking at.
Right.
So it looks like a nighttime image. Sorry, yeah, it looks like a nighttime image, but it actually is a daytime image, but it's just in a tunnel. So that's an edge case. So we can use these types of visualizations to get edge cases to figure out where we might need more data or to do something with pre or post processing or with our model architecture itself in order to build a better model, essentially. So I can stop here, but I'm also happy to go on and continue because there is more that we can do.
Right. Is there a way to visualize the size of the?
Let's take a pause here. Hold on to that one, Satya. We'll take a pause here and do our trivia question, and then come back to see some more cool Voxel51 stuff. Jacob, if you wouldn't mind unsharing your screen for a moment while I talk to the audience. Thank you. So, folks, if you need a reminder or you're joining us for the first time, one of the things we do on this show is give away something to you in the audience. I am about to ask a trivia question here to the Zoom audience, and the first person to answer that correctly will win the OpenCV course of their choosing. You can go to opencv.org/university to see what courses are currently on offer. In fact, there were just some recent updates. Do you want to do a couple sentence explainer of OpenCV University for the newbies out there, Doc?
Say that again. Sorry, I was looking at the chat section.
It's all good. Do you want to do a 2-sentence explainer on OpenCV University for the folks out there that might be joining us for the first time?
Yeah, so OpenCV University is basically, it is our program. We have a collection of courses in it, in OpenCV, obviously, but also PyTorch and TensorFlow, generative AI. And, if you don't know Python, we also have a Python crash course. So the idea is that, compared to other courses on the internet, we have a very specific focus. We want to make sure that you are ready for a career in AI, right? And that is the main reason these courses are also kind of long, right? You have to spend about 3 to 4 months to complete. For 2 of these courses, you'll end up spending about 6 to 7 months. And that is what we recommend if you really want to switch into a career in AI, 1 computer vision course and 1 deep learning course, right? So that's what OpenCV University provides. And you should, whoever wins, they should pick either, one of the heavy courses, right? Fundamentals of computer vision and image processing, if you're interested in traditional computer vision, or deep learning with PyTorch, or deep learning with TensorFlow and Keras, either one you should choose so that you can, those are bulky courses and they really help you start in AI.
Yeah, definitely. And there's, as you said, there's quite a few courses on offer, and these were created by professionals in the field. So get ready to answer today's trivia question in the Zoom chat. If you answer anywhere else, I will not see it in time because Zoom is where we kind of do the first broadcast, and then this gets syndicated out to all of our other platforms. So if you want to win the trivia, you need to be in Zoom. And you can always get to Zoom by going to opencv.live, and it will just bounce you into the Zoom app. If you have won in the last couple of months, please do not answer and give someone else a chance to win. This is going to be, I think, a quick one. I'm second guessing myself already. So earlier we talked about the origins of the name Voxel51. What was the joking reason given for the name Voxel51 out there in the chat? Oh
You got
man,
that
Andrew
immediately.
just sniped me on this one. Holy crap, dude. Andrew Olson, before I even finished asking the question, the correct answer, it was to hosts and panelists and not everyone, but we're going to count it because it was the first business idea that worked, the 51st one out of 50 failures. Congratulations, Andrew Olson. Send one email to phil@opencv.org with the course you would like, and we will get you that course as soon as you send the email. Basically, the OpenCV Courses support team is on it.
So Andrew had pre-typed it. They are reading your mind, Phil.
I think maybe I think maybe so. Like it's after 137 episodes, we've just like Vulcan mind melded with the audience at this point, and I think they're choosing the questions now inside my mind for me to ask. It's a
Right.
very unsettling scenario.
So these days, about 10 AI bots join our webinar. I'm wondering how long before there are bots who win these competitions. Right? The bots have
I
been
don't even
sent
want
to
don't even want to
win
think
the
about it.
competition to this trivia question.
I also didn't count them yet today. We'll see what usually they'll chime in with like 2 or 3 minutes left in the show with the summaries. And so I think last week we had 5, which was down 1 from the previous week. Anywho, that is enough for trivia today. We've got like 10 more minutes left. We can show some more Voxel 51. We've got a few questions out there.
I had a question on my own, which
yeah.
So one question was that the most common problem, not the most common, but one of the most common problems is the size of the object that you're trying to detect or something, right? So usually you could be doing very well on certain sizes and not so well on certain other sizes. Is there an easy way to check that kind of cluster as you had shown before?
I think you're muted still, Jacob.
So I was looking for all the buttons and everything. So yes, there are multiple things that you can do. I'm going to pull up for a second our filtering cheat sheet. So Voxel51 has great documentation. We have things like tutorials, which includes, for instance, a tutorial on small object detection right here. So this uses Sahi, slicing aided hyperinference, to detect small objects in your images. And you can pair this with whatever base object detection model you want. And then you can like filter on object size and whatever else. But we're going to just go straight to the filtering cheat sheet, which includes the filtering that we need to do this. And we can go down to the section on detections and see that there's already a recipe here for us to detect, to filter on bounding boxes of various sizes. So I can just take this right here, copy and paste it in, and let me filter for bounding boxes greater than some, let me do the relative size. So I'll do rel, and then I'll do this greater than like data set. So now we're getting all of the labels in our predictions field that have a bounding box area that takes up more than half, 50% of the image size. We can set this as the view,
Right.
um, in our app and go back over. And now we see this propagated up here. We've got this
Yeah,
filter
nice.
2, which includes this only bounding boxes above 0.5. In our predictions fields, let me turn off these so we just see predictions. And now we can see that there's way fewer predictions here, only predictions that are pretty large. We could do the same with small ones. We could combine this with filtering on the class name or the confidence score or whatever else. But yes, this is absolutely possible. And in fact, I can't show it to you today because it is not yet out yet, but our newest version of Voxel GPT, so our AI assistant for the 51 app and query language, which is going to be like embedded in as plugin into the 51 app,
Wow.
that includes the understanding and knowledge of filtering based on bounding box properties and sizes and things like that. So you won't even need to remember the syntax and copy and paste it. You can just ask it like filter for bounding boxes above some size or below some size, or images with more than 5 bounding boxes or fewer than whatever bounding boxes. It can do all that stuff for you, as well as filtering based on geolocation attributes and date times and whatever else. So
Wow.
I'm
That's
not going to
exactly what
share
I
like
had in mind. But I was going to suggest that why don't you make the search, right? Almost it could generate the query for you, right? You just ask it, and because frankly, any tool, right, especially visual tools where there are a lot of buttons and a lot of options, they become very difficult to remember. You have to become an expert in that, and then you start gaining, for example, Photoshop or any of these tools. They're very powerful, but at the same time, you have to remember a lot of things. And for users who are not embedded in it every day, it becomes very difficult. But if you have something like that, or just filter it so that you didn't have to go and cut paste code, which is not a big deal. I mean, you can still do it, and it's very powerful. But if you didn't even have to do that,
totally
very,
agree.
very neat. Yeah.
So that will be possible very soon.
Yeah.
We're trying to get that out by CVPR. So
Wow. Sweet.
yeah, it's
Exciting. Yeah.
like very top of mind right now. Before we
Good
go,
luck,
I'll
team.
show you like 30 seconds of a few more things. So everything I've showed you so far is with image datasets, but 51 also works with other types of datasets, including here's some PDFs right here. This is a PDF of my PhD thesis, including some OCR text, and I've generated these with the Tesseract OCR engine, and then you can generate an index and embed all of these text blocks and search through them semantically. It works with videos. So I've got a quick start video data set here, but it work with whatever video data set you want. And we have, you can play it. You can see that these are tracked. So
Oh,
for
nice.
instance, if I turn off these tracks and I'll keep the tracks on, but you should see that here,
ID.
yeah, the ID is preserved. Like this is car 3, this
Yeah.
is car 8, and they're preserved over time. And so we have like some notion of the index associated with each of these objects and the tracks.
I think I recognize. Is that 9th Street on the top left there in San Francisco? No, it's not. Never mind.
Iberville.
Yeah, definitely the wrong street signs.
It also works with other types of data entirely. So here, if I go down to where's our quick start groups data set, we can look at things that have multiple. So we have a left and a right stereo image, and then a 3D scene that we can interact with, including
Oh, wow.
points, LiDAR and radar, bounding boxes for our 3D detection objects. We can interact with this entire scene. We can turn things on and off. We can change how we're coloring it. We have support for meshes now as well, and like .ply, lots of other 3D data. I'm not going to go into that, but the point is that it works with a lot of different types of data, and basically anything that you might want to visualize and interact with in a semi-structured fashion, filter and query, perform analyses on. 51 is helpful for interacting with it on the data set level. So that's all I wanted
That
to
is
show.
super cool. Like I think you intelligently saved the coolest looking thing for last there. That was pretty boss.
Very nice.
Yeah. I mean that's about it for the show. Like Jacob, any last words for the audience here before we call it an episode?
thank you so much for staying through this. We are open source as well. So if you want to contribute to the project, and I don't mean monetarily, I mean contribute your code, we have a really vibrant open source Slack community, which has about 3,000 people in it. We've got meetups. We have a meetup network for computer vision and AI events that we run. We have multiple events per month, in person and virtual, with over 15,000 members now in the network. So I would encourage you to join one of these types of communities. You can contribute code to the 51 main repo or to our plugins ecosystem. Tons of ways to get involved. Feel free to message me. Just however you want to get involved, there are ways. So thank you, and check out 51.
All right. Thank you so much.
Awesome.
It
Yeah,
was
great
just
presentation, man.
illuminating, and I'm going to instruct my team to look deeper into Voxel51. Also, this is like I always like to say that, you know, a good data scientist is a good data janitor, right? So if you're not spending enough time with your data and cleaning it up, then you will never get the kind of accuracy that these top people get, right? Top engineers, they always spend a lot of time with their data, and that's very important. And Voxel51 makes it really easy. I mean, I'm really impressed with. I've seen demos of Voxel51 just a few months back, and now I see so much more has been added. So a really, really impressive work there.
Well, that's all thanks to our open source community, because without them, we would be nowhere.
That's awesome. That's awesome.
Ditto. Why don't you take us home, Doc?
Thank you both so much for having me. It was really great to be here.
All right. Thank you so much, Jacob. And thank you so much, Phil, for organizing this show. And as always, I really want to thank our audience. You guys are amazing. You show up every week, and we have a great time introducing new tools, new people to the show, and we'll continue doing that. Thank you.
Yes, absolutely. And our guest next week is nobody, because we're off for CVPR. Quick reminder to everybody, if you're in the Seattle area, CVPR is totally worth going to. Super fun event, you know, very academically focused, but also extremely good parties. And OpenCV will be there. Stop by booth 1920, get yourself some OpenCV swag, some buttons, some stickers, and see us out there. In 2 weeks, our guest will be a couple of folks from ARM who are going to talk about using OpenCV on Android as part of the OpenCV and ARM collaboration, which we are super excited about. You can already register for that event. Same bat time, same bat channel, June 27th, wherever you watch OpenCV. I've got a couple at the end here. I just want to remind folks, I am also doing another streaming show Tuesday nights. It has nothing to do with computer vision and AI for the most part. Occasionally, the guests will talk about that. But I play video games. I interview my friends, such as Canadian author David Demchuk, Kwabena Agyeman from OpenMV, etc. You can check that out on Twitch at twitch.tv/extrafuture or on YouTube at Phil Nelson. Take care of yourselves out there, folks. Take care of somebody else if you can, and have a great day wherever you may be.
Thank you so much. Bye.